Hello there, this is Alana Tucky, and in this video I want to show you how to use the TI-84 calculator to help you run a hypothesis test for a mean, in particular a t-test for the mean. So from this problem in the notes, we have that according to the United States Mint, quarters weigh 5.72 grams. A researcher is interested in determining whether the new state quarters have a different weight than the old value of 5.72 grams. He randomly selects 18 state quarters, weighs them, and tapes the following data. So there's our data right there. And notice we didn't find out anywhere in the problem that it was normally distributed. So that means that we need to have this lovely graph here to prove to us the data is normally distributed because n is only 18. It's not larger than 30. All right, so how can we use the calculator to help us run the test? I mean, when you run a hypothesis test, you have to do all these different steps. But to actually run the calculation part, you can use the calculator to help yourself do a lot of the heavy lifting. The calculator can find this 5.702, which is your x bar value. It can find the s value of 0.04965, and that n is even 18. It'll count the numbers for you, and it'll tell you the test statistic and the p-value, all when you run the t-test. Now, if you're going to do this, you're going to need to have the data typed into the calculator, or you're going to have to know the mean and the standard deviation and the n size on its own. So let's grab a calculator, go to Stat, go to Edit, clear out any old data you might have, which I have some old data from a different problem in here. I don't need L3 either. All right, and then you're going to type all the data points in. So 5.7, 5.67, and so on. All right, I'm going to pause you and I'm going to go type in the data. One sec. All right, there we have all the data typed into L1. All right, now to run a test, a t-test, you have to do Stat, move to the right to Tests, and you want number 2, a t-test. So you're running a t-test for the mean. So pick number 2. And then you have an option at the top of either data or stats. So data, I will choose because I actually typed in a column of data, oops, not there, from my actual problem. So if you type in the data from your actual problem, then you'll select data, which I did. And then mu0, the 0 comes from your null hypothesis. So when you look at your null hypothesis, oops, not there, stop that. There we go. We can see the null hypothesis that we assume is 5.72. We assume the mean weight is still 5.72 grams, unless we can prove otherwise. All right, so 5.72. Our data list is L1. That's where we typed in our numbers. Frequency always leave as 1. And then we have to choose, do we want a not equal to, a less than, or a greater than? So what you're looking at is your alternative hypothesis. In the alternative hypothesis, you can choose one of those three. So we can see our alternative hypothesis is a not equal to because it says different. See that word different? So that means that I want to select the not equal. So I'm going to press enter on the not equal. I'm going to go down to calculate and press enter. And when I do that, you can see it gives you the x bar value right there of 5.702, gives you the s, which is 0.04965, tells you that n is 18, tells you your p-value is 0.147, and your test statistic is negative 1.519. So it gives you all those important pieces of your test right there. So notice, by the way, also, since it's a two-tailed test, the calculator actually knows that it's two-tailed and it already has it all figured out. So the p-value is 0.147 is actually both sides of the tails put together for you. So it's not 0.147 on the left and 0.147 on the right. It's 0.147 for both the left and right put together. Nice, huh? Now, if you didn't have the data, let's say for whatever reason you didn't have the column of data in the beginning, right back here, and all you had was the numbers 5.702, 0.04965, and 18, you could still run the test. What you would do is you'd say stat tests number 2 t-test, and then instead of data you would pick stats. Now I just ran this so it knows the numbers that I just ran, so this is going to seem silly, but I'm going to type them. So 5.702 and then 0.04965. For whatever reason, let's say it was given in the problem in 18. You didn't have the data and you had to do it this way. Well, you could still run it. It would be like this. right? Slightly different. See, negative 1.538. That's because we're rounding a little bit here, right? And that's okay. That's what, if that's the data or the statistics you have to run it from, then so be it. Okay, and you can see 5.702, 0.04965. Those are the values I entered myself. A lot of students want to know what the draw feature looks like, so let me just show you real quick. If I click number 2, t-test, and then I go to draw, so down, calculate, to draw. Actually, let me do data again, just so it can be the actual numbers we had in our problem. So I'm going to choose data. That'll be a little bit more accurate. And then I'm going to go to calculate, or excuse me, to the right to draw. All right, and then it should be drawing any second now. It's a little bit slow because it's quite a difficult function for the calculator to graph. But there it is. There's the left-hand tail. And there's the right-hand tail. Now, unfortunately for you, a lot of the times what we're dealing with is far in the tails, so far that it looks like it's not drawing anything. So the draw feature is not as useful as you might think it is. It's useful in this particular problem because the tails are pretty big in this problem, but that's not always going to be the case, so be careful. All right, so there we go. And notice it's telling you again the p-value is 0.147 and the t-test statistic is negative 1.519. All right, so that's how to get the calculator to help you with the p-value method. Very, very helpful. The p-value method is basically how all computers and calculators work, which is why it's so useful. It's kind of the modern way to run tests. Since our p-value is not small, we don't reject, blah, blah, blah. Now, the other thing to help yourself with is the classical method. So if you're using the classical method and you want to help yourself find these critical values for step 4, which you can see right here, I said we're negative 2.110 and positive 2.110. All right, now where did those come from? Well, your alpha was 0.05. And since your alpha was 0.05, you cut it in half because it's a two-tailed test. If it was a one-tailed test, you'd stick with all of the 0.05. But since it's two-tailed, you cut it in half, 0.025. So you have 0.025 on each tail. So then you could do one of two things. Oh, and don't forget your degrees of freedom is 17, right? Right there. Okay, so you could go to the table that you have, the T table. And you could go to the 0.025 column right here and drop to the 17 row, and there you have it, 2.110. So that's one way to find it. Now to get it from your calculator, you would hit, well, quit and get out of here. Distribution, number 4, you want inverse T. And again, only 84s have this. We've run into this trouble before. If you have an 83, you can't do this. So it's 0.025. 17 is our degrees of freedom. Paste, enter, and there you have it. Negative 2.110 when you round the 8 rounds the 9 up to 10, right? So it's the same number as you got from the table, or that you got from the table. So that's how to get the calculator to help you a little bit with the classical method. But the classical method, by definition, doesn't really use the calculator to the same extent that the p-value method does. P-value method is what calculators and computers are invented for. And one other thing real quick is that if it's a two-tailed test, then if you find the negative value with the calculator, then the positive value has to be there, and vice versa. If you find the positive value with the table, because that's all these tables have are positive values, then you know that the negative one must also be there because it's a two-tailed test. All right, we're all done with running t-tests with the calculator from both raw data and from statistics. So now you know how to do both.